Welcome everyone to the Preparing for the NGSS Science Assessment webinar. We're excited that y'all are here. So first, howdy y'all. My name is Brendan Finch. I taught middle and high school science for 7 years, and I left the classroom called rocketlet.com. That was in 2014. And we started building InOrbit in about, I think, 2019. And our assessments and our platform have been growing since then. I wrote a lot of the assessments originally, and now we're spending some time building out some new resources that are kind of like little bite-sized phenomena and sense-making tasks. So think, like do nows or exit slips are kind of like scaffolded practice for students. And that's what I'm spending a lot of my time on right now. And I'm excited to introduce my wonderful colleague, Julia.
Thank you, Brendan. So my name is Julia, and I was a teacher for students in the elementary level. And then I was a tutor in the Dominican Republic, which was very fun. And I've been building materials to support teachers in districts with their NGSS implementation for the last 2.5 years with InOrbit. I'm InOrbit's district engagement manager. So if you're interested in trying out the platform, if you still haven't, please feel free to shoot me an email and I'll take it from there.
Cool. Thanks, Julia, for introducing yourself. And now let's dive into our webinar du jour, which is we're preparing for the Connecticut NGSS science test. Our objective today is to analyze some released test items and dive into some resources and strategies from our partner at Weston Central School District. Shout out to Weston Public Schools. Shout out to Beth, Lancaster. And we're going to be here for about 60 minutes. We may actually finish a little bit early. But we're recording this, and so if you have to head out early, we are going to be releasing the recording probably either Thursday or Friday. So you may see that in your inbox soon. You can share it with other people. So we'll start off by going over some released test items and doing some analysis of those items. And then we'll scaffold up to some three-dimensional questions. We'll talk about waffle makers and cross-cutting concepts, which is kind of fun. Beth and Lucas Walker, big shout out to Lucas Walker. He is the teacher who had the idea that is featured in this little video clip. Beth is not joining us live, but Beth is going to be popping in to kind of share some things that she's been thinking about with y'all. We'll look at InOrbit items and also how to use phenomena for test prep. One of the things that we've been focusing on is shifting from just phenomena as an instructional tool and an assessment tool to maybe there are other more flexible ways that you can use phenomena. So we're going to go over some of those with y'all, including using them throughout a unit in different ways, daily do nows, SEP practice problems. And also, if you have questions as we go along, don't be shy, write them into the chat. Or if you're watching this as a recording, go ahead and write questions into the comments of this video and we'll respond to them. Thanks, y'all. Cool. Let's get started. So kicking it off, we always like to introduce InOrbit to give you some context around what we do and how we do it. So InOrbit involves just a couple things. It's really simple. So we find all these phenomena. So for y'all so in your context, you have lots of really rigorous questions that students have to take in the Connecticut NGSS test. And so we find all these phenomena, which are these, sort of brief examples of things that happen in the natural world that can be explained with science knowledge and the skills, the SEPs. And so we find all these bite-sized phenomena. We are currently writing hundreds and hundreds more phenomena. So throughout the next few months, you're going to see hundreds of additional phenomena pop up on the site. And we're always, with those phenomena, writing lots of scaffolded questions. We're going to go over the different question types that we write on the site. Our goal is to help you to scaffold up to those rigorous performances on the NGSS test. And with all of those questions come really juicy and detailed data. And so we're not just looking to say, students missed this performance expectation, or in this large group of SEPs, your student struggled. And we'll break down each individual student and each individual SEP into the component elements, which are the smaller parts within each grade level band. So at 3.5 or at 6.8, we'll have really, really discrete things that we will explain, where students are struggling or where they're being most successful. We'll dive into the reports a little bit later after we dive into some of the question types that we have on the site. But the goal is really to be really specific. And if you would like to make a meeting to talk to, it's going to be Julia. So I'll be honest. Then click on that link that Julia just dropped in the chat. And if you want to start a pilot on your own, there's also another option. So you can click on that explore.inorbit.com link, and it'll take you into a free sort of like pilot. So if you're like, I don't want to talk to these people, that's a little hurtful, but it's fine. And so you can go ahead and explore the site on your own if you click on that link. Now let's dive into a little bit of the, some practiced items and do some little analysis of those items. So we're really excited to jump into that. And to give us a little bit of context is our friend Beth. Beth's amazing. She's at Weston Public Schools. She's the 612 Science Curriculum Instruction Leader. She is at a meeting today, and so she was not able to join us live, but we partner with her. And so we've worked with her actually from 2 different sites that she's been at. And while you listen to what she says in this video that's going to come up in a second, what I want you to think about are these things. So how does Beth coach students to approach questions? So I think there are things that teachers need to do, and there are things that students can do. And so I want you to think about how students are approaching those, and what opportunities do teachers need to give students. So that's really, really important. In addition, what resources have been helpful? So what are they leaning into to help those teachers and students? And Beth is by far one of the most thoughtful leaders that we work with in Connecticut. And so we love having her here. This is actually the second webinar where she's been either physically present or virtually present in order to share her ideas. So let's go over some successful strategies from Beth for preparing for the Connecticut NGSS test. Give me just a second to pull that video up. Boop, boop, boop. And I'm going to take it away, Beth.
One of the strategies that we've found to be very helpful is asking students to take some time to look at the questions that they're being asked, which on our assessment and also on InOrbit are positioned on the right-hand side of the screen, so that then when they go to look at the information being provided in the stimulus, the phenomenon, the figures, the data, that they're reading for information along the way, that they can pull out some information and they're already familiar with how they might use that information to help make an informed choice on their questions. When students have exposure, right, to the types of assessment items that they're going to see, then they feel more comfortable, right? They walk in there confident. So not only do they have a toolbox of strategies, but they know what they're going to be asked to do. And in using our state assessment, interim assessments, or orbit questions, they're aligned to the standards. And we know that our state summative assessment is aligned to the standards. So using these tools really help students enter into the assessment well prepared. I've worked with some teachers in using some of the data that we've gotten specifically from InOrbit because it breaks down based on the different dimensions. And so even though we adopted the standards, right, a number of years ago, there's been a little bit more of a focus on, 2 dimensions and not the 3rd dimension, and really using that data to focus in on, like, is there an area that our students are not, demonstrating proficiency where they are in another particular dimension. I'm thinking cross-cutting concepts in particular seem to be that one dimension that really makes everything accessible to all students, but is the one that is a little bit more of a leap in terms of how do we incorporate that into our instruction, using the data to really dial in on which dimension, whether it be a science and engineering practice or a cross-cutting concept, are we noticing that there might be some room for work, and setting goals around that, and then an action plan that incorporates some professional learning around that particular dimension, and then instructional strategies to implement that. So that I have found has worked really well this year in my new position working with teachers, is sitting down and let's pick one that we want to really work on this year, and using that data to inform it. One of the strategies that we've found to be very helpful is...
Sorry, y'all. Let me pull this back up. Thanks for your patience. Thank you so much, Beth, for sharing some of your thoughts. It is really, really helpful to hear some context around that. So just to kind of review some of the things that Beth talked about, so make sure that students have exposure to these items. The Connecticut interim assessments are a great way to give additional exposure to students so that they get used to either the layout of the assessment, or they use that to just practice what these rigorous items look like and feel like and how they approach them. I really, really like the idea of breaking down the phenomena and the questions for students, where students go in, they read the questions, they have some look-fors, and they go back to the phenomena, which is really, really fantastic. And in addition, so we'll talk about this later on too, Orbit's reports are super duper detailed. So what we're looking to do is give you very specific next steps for what to do in your classroom or your school or your district with respect to a specific dimension, like a cross-cutting concept at this grade level band and this specific element of that. So we'll dive into that in a little bit. Cool. Thank you so much, Beth. We really, really appreciate you sharing your thoughts, and I hope that that was helpful for y'all that are here as well or are watching. So let's dive into a practice item. And this is all about these flies' eyes. It's about this genotypes and phenotypes of 3 different flies. And we're looking at the wild type, the bar-eyed, and the bar-eyed. So either heterozygous or homozygous. So this is one of the release test items that students can see in the practice science test for 8th grade. The context that's given to kiddos is that flies with bar-eyed phenotypes cannot see as well as those with wild type phenotypes. The genotypes and phenotypes of 3 flies are shown in figure 1. That's what's on the right-hand side there. So the question that is asked of students is, organize the statements that complete the chain of events, explaining how the bar-eyed mutation reduces a fly's eyesight. So what we're looking to do is to connect the dots between how either, the chromosomes or proteins and then traits. So this is really all about that DNA to proteins to traits connection. So in the chat, what I'd love for you to consider, and so students have to drag and drop each of these different options into there. What I'd like you to consider is, how are students applying their understanding of DNA and proteins to make sense of this phenomenon? And maybe another way to think about this is this a memorization question, or are students having to make sense of and apply their knowledge to something new? So go ahead and take a minute and reply in the chat. If you're watching this recording, you can reply in the comments as well. In the chat, so students need to pretty deeply understand what the path is from chromosome or DNA to protein to trait. And so in this case, they can drag and drop those different things. They need to memorize that there's some combination between DNA and proteins and traits. But what's really interesting is they need to understand how the genotype leads to the phenotype and connect those dots. And so it's something that students need to really deeply understand and then apply that understanding to this specific scenario. So this won't be, the bar-eyed type won't be the thing that they are working on in instruction, but it'll be, a different phenomena, a novel phenomena. And so in this specific example, we do see that students really need to have a deep understanding of the concepts of these standards of this, DNA to proteins to traits, and they need to be able to apply that to these questions and all the other questions on the test, which I'm sure y'all are painfully aware of, are at an equal or even greater rigor than this question is, where students need to really deeply look at the models, be familiar with those different types of models, and then be able to apply their understanding of how traits are expressed and how chromosomes and proteins are linked to those that trait expression, which is really interesting. Cool. Thank you so much for going over that with me. So let's dive into a little bit more detail around what are the 3-dimensional standards. And so in these slides, we're going to kind of go over that standard that question is based off of, and then take a look at sort of dissecting that standard into its component parts and thinking about how we can break that down and scaffold students up to this rigorous performance. So this is a performance expectation, and more specifically, this is MS-LS31, so it's middle school life science heredity performance expectation, where students are asked to develop and use a model to describe why structural changes to genes, these are mutations located on chromosomes, may affect proteins and may result in harmful, beneficial, or neutral effects to the structure and function of the organism. And so for this standard, students are using the 3 dimensions, and we saw those at the bottom. So they're the DCIs, which are kind of like what students need to know. They need to understand inheritance of traits and variation of traits. So looking at both how, traits are inherited and also how those traits can be varied in populations. They need to use models. What's really interesting is it says develop and use a model. So students didn't need to develop that model, but they did need to use those models that were given to them in order to answer the questions, which is another way that those developing using models questions can kind of take shape. And then they need to identify, so structure and function and the link between those two things. So more specifically, looking at microscopic structures and how those may lead to macroscopic functions. So this is a really specific piece of that cross-cutting concept where students need to link their understanding of that structure of the chromosome or the DNA, and then how that links to the function of those, those proteins, and therefore the actual phenotype that will result from that. And so that's what this performance expectation is all about. And in that question that we see students using the models that were given to them. They need to apply their understanding of those, inheritance and variation of traits. And then also they're using the cross-cutting concepts of structure and function in order to, explain what is going on within this question. So it's really, really complex standard and really, really complex performance from students. So these types of phenomenal questions and these types of phenomenal, phenomena are what we need to see students practicing. And what Beth was mentioning in her recording is just that, if we don't give students the opportunity to do these things, it's going to be really hard for them to then apply their understanding to these on the NGSS test. So super important that we give them opportunities to apply the SEPs, those DCIs and cross-cutting concepts to all scenarios. And so to kind of like parse that apart even further, we want to think about how we might be able to scaffold students up from representation to rigorous sense-making performances. So at InOrbit, we think very, very deeply about that 3-dimensional, that sense-making question. So I would call that question that we just saw a 3-dimensional question. I'm not sure if it's full sense-making, but students are definitely applying aspects of all three dimensions in order to answer those questions. And so those sense-making questions are an end goal. So we know that that was a tough question, and students would struggle to answer that question at the beginning of a unit or of understanding of heredity. However, we want to make sure that we give them, lots of opportunities to take their knowledge and use that through the lens of the cross-cutting concept and the SEP. And really specifically, they need to explain why or how something is happening. So it's really important. And so in that question, it's really interesting because it's drag and drop. Students aren't constructing an explanation, but they are showing how, either the bar-eyed or the non-bar-eyed phenotype results from, different combinations of DNA to proteins to traits, which is very interesting. And then, so what we think about a lot is how we might scaffold students up to this point. And so that might look like identifying these invisible steps that we're asking students to take. So not giving them, just a full scaffold of that rigorous question, but what are some lower level questions that we can ask? And how can we gather data on those, question types in order to best support them as we move forward? So as Beth mentioned in her video, how do we, take students and identify the differences and the changes that are made between this DCI only, so I know things, to I'm able to represent them in a three-dimensional, sense-making performance. And so that three-dimensional performance at the end is the end goal. We want to figure out how can we lead them from I know things to I can apply them to these complex scenarios. And so to do that, we're going to use another phenomena, which is why should we be careful around X-rays? So on InOrbit, we have hundreds of phenomena. I think there are over 1,000 on the site now, and they're written for grade levels 3 through 12. So you can apply, or you can ask students to apply their understanding to lots of different things. And so this is all about radiation and the impacts of X-rays on DNA. And we give students a couple of figures, some chromosomes, some nice little DNA strands to look at there. And we're just going to kind of present this scenario and ask students several questions about this. And again, I want you to think about this through the lens of how can we scaffold students up? So I'm not going to give students a rigorous performance right away. And if they don't get it, bummer. But instead, I'm going to ask many different question types that sort of lead up to that really, really rigorous final summative performance. And so the question that we ask at the very, very end, we call these questions summative questions or sense-making questions. And so this question is, how can X-rays change our traits? And so we ask them to create a model. So they actually have to physically develop a model on the page by drawing and writing to show how X-rays can lead to mutations and how those mutations might impact our traits. So again, there's a link there between that developing using models, that inheritance of traits. So how are those traits, those mutations, how do they impact phenotypes later on? And then finally, how does structure relate to function? How does the structure of that DNA and the changes that X-ray may cause and mutations that it may cause, and how does that relate to the function of the DNA and thus those traits that are developed from there? All right, great. So what we want to think about now is how we can bring students from understanding that DNA impacts traits and ask more specific questions that help us to gather useful data around that three-dimensional performance. And so what we at InOrbit posit is that you can use two-dimensional questions in order to do this. So a two-dimensional question may involve the DCI and the cross-cutting concept. So students' understanding of structure and function is applied through the lens of that DCI, or you can ask about their DCI and the SEP. So developing these models and their understanding of inheritance or variation of traits. And through those different question types, we can gather data on, okay, so are students struggling with all of these things, or is it just the SEP or the cross-cutting concept or the application of all three together? So that's what we're looking to do with InOrbit. So I want to walk you through a couple different question types that we have on the site to sort of build up to that point. So at the very, very beginning, we want to assess whether students have the core knowledge, the DCI, understanding that is needed to apply to make sense of that phenomena. Because if they don't know that there's a link between DNA and proteins and thus traits, it's going to be rough road for them moving forward. So the first questions that we'll ask are around the DCI LS3B, and we'll say changes in DNA called mutations can change which blank our body produces. And so what we want students to identify is that proteins are changed by changes in DNA. And so all we're doing right here is we're just asking students about their knowledge. We're not interested in the cross-cutting concept. We're not interested in the SEP, not explicitly in this question. Though I think in all questions, you'd be like, oh, technically, they need to look at them, or it's possible that they could use structure and function. No, this is really a knowledge-only question, and that's really important. And then we'll go a little bit further. So we'll ask our second type of question, which scaffolds up. These are two-dimensional questions. So we have two different types of these. So this one is called the content and practices. It's the DCI and the SEP. And so we'll ask which statement best explains the phenomena happening in figure 2. So students need to look at the diagram. They need to look at the model that we give them, and they need to understand their inheritance of traits. Now, we're not asking them about how structure and function are connected. We're just asking them to parse that model that they're given. So it's really, really important here. If students are struggling with that abstract representation through modeling, then we can pull that out through questions like these. And then we can ask other questions that get to other parts of the standards. Now we can ask about the DCI and the cross-cutting concept. And so in this case, we say, how do the changes to the structure of DNA mutations alter our traits? And so again, has the structure of DNA lead to those functional parts of, proteins and then those traits? And so we ask this question very deliberately, leaving out. So students, they could look at the models there, but they're not required in order to answer the question. That's really, really important. We're not just putting a model on the question and saying it's a modeling question when students can just answer this out of an understanding of the DCI without looking at the model. So that's really, really important. Despite the fact that there are models here, that's not just like a pretty picture that's added onto here. It's actually, totally accessory to this. They don't need it in order to answer the questions. All right, and then we also have, in addition to those free response questions where students are drawing a model or writing a CER statement or something, we'll have what we call sense-making 3D questions that are multiple choice. And so the idea here is that it's one step down from what students have to do on that, really rigorous item that we looked at from Connecticut, and definitely a step down from developing their own model, which is, pretty advanced. That's a challenging thing. So we'll ask students things like this. So your classmates are putting together models to show how mutations affect organisms on a molecular level. Which student's model best illustrates this? And so we need them to analyze the 3 different model types that are down at the bottom. So it's very similar to the fly's eyes phenomena, where they have to choose, which order of, operations we want here. And it should be chromosomes to proteins to traits. And that's really, really important. And so in this case, we need them to choose the model where the student develops that. So they're using that model, they're not developing on their own, which is really similar to what they're doing on the fly's eyes question. And so in this way, we're able to take all of these different question types and sort of scaffold students up in their understanding from, what's the core content? Do you understand the DCI here? Do you know how traits are inherited and vary? And then we can ask them questions about the content and the practices. So do you understand the SEP with that knowledge? Then we can also ask them questions about the content and the concept. So do you understand the cross-cutting concept, with that knowledge? And then finally, we can ask them these sense-making 3D questions, which are kind of the really advanced questions that show students that they do have readiness for that really, really, really rigorous test and those items in there. And so on that, so when you're on our site, InOrbit, you're going to see these types of reports in the dimensions tab. So this is our dimensions report. What this does is it breaks down things like the DCI, so structure and function, and it shows us what are the parts of that standard where students have been successful relatively, and then what are areas where they need more help. And so in this way, we're able to take each of the performances that students should be showing, their knowledge, their understanding, and we can figure out where we need to apply some pressure. And so as Beth mentioned earlier, the cross-cutting concepts are kind of like the lost part of the standards so often, even though they make things very accessible to everyone. And so in this way, we can look at, okay, maybe it's, energy and matter flows or scale, proportion, and quantity that kiddos are struggling with. And if we click into that, we can find, we can see that the observed function of a natural and design systems may change with scale, and that phenomena that can be observed at one scale may not be observable at another scale. So I'm thinking of like micro, macro things, like DNA and traits is a good example of, you just see that there's like different kids from a pair of, parents, and like each of those offspring have maybe similar traits and maybe not similar traits, but they're microscopic parts that lead to those larger functional observable traits and phenomena. Cool. And then same thing for the SEPs. So the SEPs are super complex, and it's not, do labs, but there are very, very explicit skills that we need students to, demonstrate a proficiency on. And so what we'll do is we'll break down each of those things so that you're able to see, what students are being successful with and where they are struggling. And then you can, apply some pressure, apply some support, or have them flex that muscle even more if they're real strong with that SCP, and see how that changes over time as you give more and more assessments. So that's what InOrbit looks like from the perspective of the reports. All right, cool. And now we're going to dive into Beth one more time and see a little bit more of what she was thinking when she was working with another teacher. And I'm really excited about this because it came out at the end of our conversation and it was really interesting. And so it was a story about scaffolding the cross-cutting concepts. And so Beth, again, is the 612 science curriculum leader for Weston Public Schools. And when you listen to this conversation, or this, it's not a conversation, she's just talking. I want you to think about, so building schemas while leaving out the content. So what are ways that we can allow practice with, like an SCP or a cross-cutting concept? The cross-cutting concept is focus here. Also, whiteboards. I don't know if y'all are using whiteboards in your classrooms, but I loved using whiteboards because it allows students to be able to do things, make mistakes, and really, really quickly iterate upon what they were doing, which is really helpful. And then I also want you to think about what are the examples that would resonate better with your students, maybe paninis, and that will probably make a little bit more sense when we get to that part of this. How can waffle makers scaffold the cross-cutting concepts? And so let's hear from Beth how waffle makers might be helpful in scaffolding the cross-cutting concepts.
One strategy that I have worked with the teacher on is actually taking some time, not a lot of classroom time, but some time to just explicitly teach like what is stability and change? What are some concrete examples that are accessible to all students, maybe not related to that particular course, but just everyday things that we might look at through the lens of that particular cross-cutting concept, and sort of launching lesson in that way so that they have some concrete example that they can work from as we now approach the content within the context of this class or this investigation that we're doing. And students in reading reflections are making connections between those like concrete examples at the beginning and the work that they're doing in the class. So it's kind of opened up, right, their perspective of analyzing something by just giving them that tool. The teacher had thought about some examples that were maybe accessible to students. An example of stability and change that he used was a waffle maker. So thinking about like, what are the inputs? What are the outputs? When is it balanced? The energy having to go in. Like there was a lot of science behind there, but it was like, oh, I know waffle maker. And then the students were like, well, why didn't you say panini maker? Why didn't you use panini maker? But it was something easy that they could latch onto. Really quick, watched the teacher, do this great mini lesson, 5 minutes. Students went and they whiteboarded, they had great examples, and they were able to identify that and then applied it to their lab investigations later on within the unit. It was a physics class. To give out a shout out to Lucas Walker, because that was his plan.
I love it. Lucas Walker, you're a hero of the physical sciences. Thank you so much for sharing all of those thoughts, Beth. We really, really appreciate it. Thank you, Lucas, for the brilliant idea. I think just one comment on this is that in classroom management, in my own context, I would often have students practice things like making posters, collaborating, sharing out, pair, share. And we would just talk about, what's your favorite, like, what do you like on your tacos? Or what kind of pizza do you enjoy? Or burritos versus tacos, like discuss. And we'd have them, build these like posters or have these conversations. And they weren't centered around, genetics or erosion or ecosystems. But we built structures wherein students could, use that content and then apply it. And so I think those classroom norms and classroom management is a really interesting analogy to use. And so when you think about things like the cross-cutting concepts, the SCPs, maybe there are more abstract and content devoid ways that we can ask students to think about things in that way, and then they can apply that to their lab. And I think what's so fantastic about this is physical science, though it's physical, it's something that you can see and feel and hear, and it's right in front of you. It's often very abstract. And so thinking about physical science and physics through the lens of waffle makers is fantastic, because everyone knows what happens when it's too hot or it's not hot enough, or you pull it out early, or you pour too much batter in there. And so anyways, that's just always the saddest thing, because then you have to clean it up. Anyways, so with that, thank you so much, Beth. We really, really appreciate you sharing that. And Lucas Walker, you're amazing. That was a super interesting and very insightful and inventive way to get students to apply the concepts of the cross-cutting concepts to something that they're familiar with. And maybe it's not, waffle makers or panini makers, but maybe it's something, that they're more used to in their classroom or on their way to school or at their homes, based on, whatever is culturally relevant to your kiddos. And they can think of their own version of this after you present them with your waffle maker or something like that. But I thought that was brilliant, frankly, and one of the most inventive ways we've heard teachers, apply the cross-cutting concepts and help to scaffold that up for kiddos. And speaking of scaffolding things up for kiddos, I'm going to kick it back over to Julia, and she's going to walk us through how we might use phenomena for test prep. So not just thinking about how, phenomena are used in a formal assessment or in the kinetic NGSS test, but like how can we prepare students, maybe not right before the test, but like all the time for stuff like this. Julia, to you.
Thank you, Brandon. Now that we have the assessment part down, as you said, let's review some strategies that we could use for test prep. So let's go back to our standard, and it is MS-LS31. And we've already talked about this, but just to recap, it is asking students to develop and use a model to describe why structural changes to genes located on chromosomes may affect proteins and may result in harmful, beneficial, or neutral effects to the structure and function of the organisms. So again, we've talked about phenomena and assessment. But how can we give students opportunity to make sense of phenomena throughout the entire unit? And what are some different types of experiences that we can give them to practice for those rigorous questions? Let's look at how we would use phenomena throughout a unit with a roadmap that we've created from phenomena from InOrbit. And in the very beginning, we could start with this phenomena that is discussing why is this hedgehog white? So since we're still in the beginning of the unit, we could consider a lower stake discussion like a whole class walkthrough. And this is all about how albinism is a genetic condition caused by mutations that affect the production of melanin, which is the pigment responsible for skin, for hair, and eye color too. So what we would include are discussion questions that target the cross-cutting concepts and the SCPs for the whole class to answer together. Moving on to the middle of the unit, we could talk about the reason why Tibetans can breathe so easily at high altitudes. Here we would consider maybe separating the class in groups to answer questions collaboratively in a printed and scaffolded group phenomena exploration. Students could discuss that certain populations living at high altitudes, like those in the Tibetan Plateau, have developed genetic adaptations that helps them cope with lower oxygen levels. And in this stage, students are answering rigorous questions that target the DCIs, the SCPs, and the cross-cutting concepts, but with scaffolding from the teacher and with support from their group too. And lastly, we could assess students by building a short online assessment to be administered individually, covering, for example, the reason why some people aren't able to roll their tongues and others are. In this case, students would grapple individually with the fact that the ability to roll the tongue is associated with a genetic variation in a specific gene, and this trait is neutral, and it has no clear impact on an individual's fitness or how much they try in middle school. I really tried doing that, never could. And this is the final part of a unit, so students should be ready to engage with rigorous sense-making questions at this point. And teachers can still provide some scaffolding if it's needed, but something very important is that removing those scaffolds is crucial for building student independence and their confidence. And at this point, we have plenty of phenomena for this life science standards, but maybe our students are not there yet. And they're starting at a level where they need even more phenomena and they need lower level phenomena in order to access these rigorous things. So what we got for that is this. We would recommend going from the on-grade level standard to a prior grade level standard. And in this case, we're going to go back a whole grade level band to the third grade standard. And here, students have to analyze and interpret data to provide evidence that plants and animals have traits inherited from parents and that variation of these traits exists in a group of similar organisms. All right, so let's look at some phenomena for this specific performance expectation. And we could first discuss how tigers get their stripes. And this is about how many characteristics of organisms are inherited from their parents and how different organisms vary in how they look and function because they have different inherited information. Then we could go over the reason why the same type of flower can look so different. And this is all about the fact that tulips can be crossed to create a mix of flower with some similar and some different traits. So they will never look the same. Okay, so main takeaways for that. To sum up, practice makes perfect. And we should be using phenomena throughout all units, not necessarily only during test prep season. And using different phenomena also provides more opportunities for students to model and practice transferring knowledge and sense making. And let's say Students are struggling with phenomena targeting their grade level band. We can always lower the stakes with a prior grade phenomena and to give further also sense-making opportunities and identify possible gaps in knowledge or skills. Another strategy you could use with this phenomena that we've already gone through are daily do-nows. And these are quickly daily activities to review prior standards and or gain experience with novel phenomena. We would recommend building one 4-question assessment per week, focusing on one performance expectation and one phenomena for that whole week. And each day's questions would build in rigor to scaffold students to a rigorous 3-dimensional question by Friday. So students would start exploring and annotating phenomena on Monday, answering DCI-only questions on Tuesday, then moving on towards 2-dimensional questions on Wednesday and Thursday, and finally a 3-dimensional sense-making question on Friday to wrap it up. So another way that we could use this is with phenomena transfer stations. And this actually came from our work with one of our partner districts in Maryland, where a teacher would print out summative assessments with different phenomena on the same standard for students to explore in groups. So a pro of this is that students keep seeing the same ideas from different scenarios, and it sparks their curiosity and helps them make deep connections. And we would have 2-dimensional questions to scaffold students up to a rigorous sense-making question. Some things to consider is that in groups, teacher can assign roles. So it's like you would read the phenomena, and then you would be the recorder, or you're the fact checker. So each student would have a role. And that's really important for everyone to feel included too. And we also would recommend that students need to have a little bit of preparation before they're ready to put their work together towards this new scenario. So it's best to implement this maybe towards the end of a unit. And finally, have a whole class debrief to make sure we model sense making and that process for students once again. And then something I also want to highlight is that on InOrbit, we also have SCP practice problems. And these are content agnostic sets of questions that are aligned to the K-12 progressions for the SCPs in elementary, middle, and high school with interesting and relevant phenomena. And we are intentionally leaving out the DCI and the cross-cutting concept to foster practicing for these SCPs. And this has been a lot of information in just under an hour, 45 minutes. Record time for us. So I'm going to kick it back to Brendan again to wrap up our webinar and to give us some next steps.
Cool. Thank you so much, Julia. I didn't know that you couldn't do the tongue. That must have, I imagine that must have been hard as like a middle schooler to be like, everyone else can. And I remember people do the 3 thing where they like fold it up. I'm like, no, I can't do that either. Okay. So anyways, thank you all very much for joining us for this session. We are super happy to be dropping those waffle maker analogies and strategies, and also talking about different actual ways that you can use phenomena throughout a unit, daily do nows, or these SCP practice problems, or using things like these sort of like connections that Beth and Lucas Walker, shout out again to Lucas, like used in helping students to prepare for that NGSS test, and frankly, just using science in their life. So if you haven't already done so, please use the link that we're going to drop into the chat, and you can find a time to chat with us. If you're watching this as a recording, you can click on that link in the description of the video. Sign up for a trial account in InOrbit.com if you're like, I don't want to talk to those people, I want to go do this on my own, or click on that link to sign up for a pilot. You can follow us on social if you're into that kind of thing. Our YouTube channel is popping, so we add new videos every couple of weeks, at least once a month, to help sort of like build this knowledge base around the NGSS. And if you're like, no, I don't like any of those things, I want to send you a personal email, then you can email us at inquiries@inorbit.com, and we would love to hear from you. Thank y'all very much for being here. We are grateful for your time and your attention, and we'll hang out for a little while afterwards to answer questions, but otherwise I hope you have a beautiful rest of your day. Thanks, y'all.